How's everybody doing? I know I'm the last session, so I'm competing with going home and sleeping and other things, right? Hopefully I'll make this worth your time. This talk is going to be about Arabizi detection and conversion. And to kind of motivate this work, Arabizi is basically Arabic written in Latin characters, like the one that you see here. If you don't speak Arabic and you cannot read this, that's perfectly normal because it's not English, right? It's just Latin characters. So basically, this says أنا عاوز أروح من أمريكا لكندا, at which point in time this means I want to go from America to Canada. And it turns out that this is rather complicated in the way it looks, in the sense that you have words like أنا and min are actually MSA words. عاوز أروح is dialectal. And then you have English words nestled into this, like America and Canada, and you can really argue whether these are actually transliterations of an English name into Arabizi, or they were actually English words to start with. But in any case, you get MSA, you get dialectal, you get English, and you get lots of context switching between all three. So to keep this, given this kind of text, what we really want to do is get to something like the one that you get in the bottom here. I don't know if some of you can see it or not, where I say, أنا عاوز أروح من, and this is completely in Arabic letters, America, and the letter lam to Canada, right? So I wanted to actually identify which words are actually Arabizi, which ones are actually English, and the ones that are actually Arabizi would just generate Arabic out of them. Okay? So really, so this is the core goal of what I'm telling you. Okay, this is basically I'm just that Arabizi is sometimes mixed into to English. There's lots of context switching, so we need to do identification, and the second step is to do the conversion. Okay, so let's start with some of the challenges. Why detecting Arabizi that is nestled in with English is rather complicated at times, or could be complicated. For one thing, if you looked at the sentence that we had before, you have words like min, right? This looks very much like men in English, right? But it's actually the preposition from in Arabic, right? But they just happen to have the same spelling in Arabizi as English. So you get lots of this stuff. That Arabizi words that look exactly like English words, but they're not actually English words. And if you just use an English lexicon to go through and say, oh, this looks like an English word that I'm used to, so that's English, no, that's not going to work, right? You need to do something a bit more clever, because it could look like a perfectly good English word, but it's not. Okay. The other problem that is common here are named entities, like the example that we had before, like America and Canada. Or if you get, let's say, an Arabic name like Muhammad, that gets transliterated into English, and then somebody starts, saying, okay, since I'm writing Arabizi anyway, I'm not going to switch back to Arabic script to write Muhammad, so I'm just going to write it in the English letters. So this complicates things a little more. And this actually, when we went down to the annotation of things, it's a bit tricky on whether this should be, classified as Arabizi or English. I don't know what you guys think. English? Any other votes? Half-half? Nizar says half-half.
I think you can write America and Canada a lot of.
Yeah, you can. Yeah. At which point in time they're Arabic words? Okay. They're not Arabizi, if I may use that word. Okay. So. And to add to all of this, social media makes life really, really interesting. So you get some things like, woo, أنا رايح to EMNLP tomorrow, right? Go figure. So this is not really English, and the two is very, whether it's an sound in Arabic or whether it's actually the preposition to in English is very unclear. Okay. So this was the, why is this? Okay, so the first challenges that I told you about are the challenges as far as the detection is concerned. The challenges for conversion from Arabizi into to Arabic is interesting also. There are many. So for one thing, if you have the word tahrir here in Arabic, it can be written in at least 20 different ways in Arabizi, because there are really no standard spelling for Arabizi at all. Okay? And to add insult to injury, the stuff that we are transliterating from Arabic into Arabizi still doesn't have a standard spelling in Arabic to start with. So you have like here, like ma bil'absh, you guys have, this was mentioned in previous talks before. So there's like 5-6 different spellings in Arabic, and you can just guess how many different spellings you get in Arabizi. And then also names like the ones that I've mentioned before, that once you go from an English name into Arabic, how it's going to look like at the end. Like, for example, the name Clinton can be transliterated in maybe 5-6 different popular ways. Okay? So all this kind of makes the conversion all that much harder. And actually kind of makes the evaluation that much harder, because if I start out with something that, that's written like ma bil'abshi here in the Arabizi, and then I generate one of those forms below, if I don't match the one that exactly appears in my reference set, then I get it wrong. And I know Nizar is going to tell me, but there is coda, right? I'm going to burn your question before the custom service, right? But I'll tell you why this is not. This can be, in real life. If you, I'll show when the way that we're doing the conversion itself, we're using, a large corpus of Arabic text in the wild that may not match coda per se. Okay, so maybe we need to codify the output somehow at the end, and perhaps this is something we can work on together. Anticipating questions before they come out. Okay. First of all, since the entire work is about Arabizi, we need to get Arabizi data, right? So where are we going to get Arabizi data from? So we took a few words that are very common in Arabic, with common Arabizi, equivalents like ihna and ashan and la'a and so forth. And there's about 120 of these, and we issued them against Twitter. Once we issued them against Twitter, we started getting accounts of people who are actually tweeting in Arabizi. Because once you go down the slippery slope, you just keep going, right? You just keep on writing Arabizi just to make all our lives interesting, and now we have jobs and we continue to live off of them because of these people. And so we identify about 265 tweeps. Tweeps is the technical term for a person who writes on Twitter, right? And once we got those people, basically we got all their tweets, and lo and behold, lots and lots and lots of Arabizi tweets. And we got about 16,000 of them. Okay? And I'm sure we can get a lot more. So to do the detection, the first part, the detection, that we want to tweak away the English from the Arabizi part, we used about 522 tweets for training, about 101 for testing, and the rest we just used them as background to collect some, to build some features as background corpus for collecting features. In particular, we were interested in building a character level language model for Arabizi. So we know which characters tend to appear one after the other in Arabizi. Okay? So it's highly uncommon, for example, that you would get an English word with the letter with the numeral 3 in the middle. But with Arabizi, that's quite common. Okay? And then we went out and labeled, for all these tweets, we labeled words as one of three things: as either Arabizi or English or something other than the two. And the ones that other than the two, things that were hashtags. Sometimes people actually used, a bit of Arabic, a bit of Arabizi, punctuation, emoticons, laughters, and all sorts of stuff like that. Okay? And we used a CRF sequence labeler to train and test to figure out whether we can identify the Arabizi words in the midst of all of this. Okay? So here are some of the features that we looked at. The first one is the word itself, not surprising. The second one is the word after removing all the repeated letters. So if I say something like whoa, like W-O-O-O-W, this will just be written as W-O-W. And we had something that would go in and would give, basically binary features, that this is an emoticon, a laughter, a URL, and so forth. And with laughters, we kind of went, in a more general definition of them. So if you get XD and colon D and ha 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 and all sorts of stuff like this, this would count as laughter, and this kind of got us into trouble sometimes because somebody would say aha, and actually I have an example of where something that looks like a laughter turns out to be a perfectly good Arabizi word at the end. Okay. The word length also, the probability of the word being an English word, and also the character level probability basically this is a character level language model, and we use two scores, one against an English corpus, so these are English, character level model on English, and a character level model on Arabizi. That's why we had, we kept most of the tweets that we collected were Arabizi to build the character level language model. So the good news is we can do this very, very well, right? The accuracy, as you can see, is about 98.5%. Okay, and the data set is available. You can take it, you can play around with it, and you can see that this is a fairly solvable problem. Okay, some of the mistakes where we got into trouble, I have some examples here, like the word shy, right? This is actually shy. This is looks like exactly like shy in English, and طب هنعمل إيه النهاردة? So what are we going to do today? So this is tab or tab, right? And so these are common between Arabizi and English, and if you say هل لعبة, right? This toy, like for example in Palestinian, so ha in this instance acts like a determiner, but it actually also appears as if it looks like a laughter, and also really, really bizarre sudden context switches, like eye drop ده يا فرح. This eye drop يا فرح. It's lots of English with Arabic. So basically the word eye, which is an English word, yes, it's the eye drop, right? So basically, the eye is now treated as if it's an Arabic word, and the gentleman had decided to put in a determiner in front of it, right? Il, right? So now it's a اسم معرف English, right? Which is really, really strange. And things that at the end, where we get single numerals that are just splattered around the sentences. Okay, so these are the mistakes. And actually, if you look at the paper, we actually analyzed almost most of the mistakes because thankfully there were not so many. Okay, now the conversion part. And for the conversion part, we tried to make our life a little easier in the sense that, we figured getting, the ya or alif maqsura right, or the proper form of the hamza was completely irrelevant. Let's just get something that looks like Arabic and then figure out what to do afterwards. So everything that we've done, we removed all the critics, we normalized the hamza, we normalized the ta marbuta and the alif maqsura and so forth. And we handled all the creations and repeated letters, and we got rid of them. So we can have fairly, reasonably looking, Arabic text. So this applied for the language models that we've built, and I'll tell you about them in just a second, right? So to do the conversion, there are two things here that we need to worry about. The first part is getting an Arabizi word, figuring that we've actually detected it in the first step, and then generating, an Arabic equivalent or Arabic equivalents. You're getting different candidates, and then the second step is using some sort of a language model to actually figure out which one of them would do best in context. So we started with roughly about 3,400 Arabizi Arabic transliterations, and they look like this: عندك and عندك and عندك and so forth, and this would be the Arabic equivalent to it. And since we didn't have any diacritics on the Arabic side, then this could be spelled in like 6 different ways, and that should be fine. And bitla, and then he ascends, meaning he ascends, and this is the Arabic equivalent to it. And you notice here that I'm not making any differentiation between MSA and dialects, and I really don't care. If the system can swallow it, that's fine. Good for the system. So these were the first, we got those training sets, the word pairs. And the second part was alignment. So we got all these pairs and we aligned them at character level. We used Giza++ to do the alignment. And then there was the phrase extractor from Moses to get us, multiple character to M-to-N character to character conversion. So you get things like N, and this will go to Alif Nun, and then I, and then go to like, for example, I is, for example. So you would get an equivalent that is multi-character on the Arabic side also. Okay. So this was the training for the conversion, and the second part was the training for the language model. And what at the time that we've done the work, we had collected about 112 million tweets, and this was over a period of about 3 months. And basically, what we did was something really, really simple, and you can actually try this at home. Is that you go and issue the query lang:\ar to Twitter, and then it will give you lots and lots and lots of Arabic tweets, right? We've actually used this method to. We're collecting about 8-9 million tweets per day. More, Walid?
Currently, it's more than 14 million.
Okay, so we're collecting more than 14 million Arabic tweets per day using this really simple trick. Okay. If you want the APIs, you can talk to Walid. Huh? Okay. And given all these tweets, basically we normalized them the way that I told you before, and we built a huge trigram language model. Okay? Now, given that an Arabizi word that we started out with basically wanted to generate candidates, and we use something like a noisy channel model. It's very, very simple. Actually, to be exactly correct, we used noisy channel model would be a good way to explain it. Is basically given an Arabizi word, we try to get all the possible segmentations, all the possible mappings from these segmentations into Arabic, and then we start generating from there, but we're just basically constraining the generation on the other side to something that we've actually seen in the wild, something that exists in our language model to start with, right? There are more details in the paper on actually how this is done, but this is fairly straightforward, right? So basically, you give it a word, and then it starts generating candidates. And what we did was we kept the first 10 candidates and threw away the rest. Okay, and every candidate has a mapping probability. So we know the probability of mapping from the first letter to the first 2 letters there, and so forth. So this is the map, just the mapping probability. And then given all the candidates, basically we combined the mapping probabilities with the language model probability to pick the one in context that would be best, using the trigram language model that we have. Okay? Once we applied both, we just kept the top one in context, and we just say, here you go, the final sentence. How good was that? So, to test, how good this was, basically we had about 127 Arabizi tweets, containing, roughly about 1,400 words. And they looked something like this. ساحل ايه؟ هو انت مش هتيجي بكرة? What North Coast? Are you not coming tomorrow? That type of thing. So this is very typical, sentence that you would get in the Arabizi test set. Okay? Now, if you look at the candidates that we generated, we were generating without using the language model, we were generating the correct one in the first position at 77% of the time. We were getting the correct one in the top 10 95% of the time. So since we were not looking any deeper than 10, 95 was our absolute best we can do, given that the candidates that we're generating. And then at the end, after applying the language model, we were getting about 88.7%, which, since I'm the one who did the work, I think is pretty good. Okay, here, fortunately, the text is a little small, but these are some of the errors that we were getting. So we actually, at the end, we got 91 errors out of got like 1,300 words or 1,400 words, and see, these are some of the errors. So in some of the cases, we got no correct candidates at all in the top 10. And some of the times, which was interesting, was the question about coda or the discussion about coda that we had earlier, is spelling variance. So like the words, online, are you going to put a wa after the alif, the initial alif or not? And talatin, is this, or I'm sorry, bitshoot, was it bitshoot with a ta or a ta? And all these things, some of them could be solved with coda. Probably online, can you codify it to get something standard? You can? You guys are great.
It's ad hoc decision.
Okay. Pick the first one. Okay. And sometimes you're getting, morphological variants like بتحبي أو بتحبين and so forth, and so on and so forth. Okay, so these are the typical problems that you're getting spelling variants, morphological variants, or that you're getting nothing. I'm actually on the last slide. No, sit down. So the conclusion, the session chair can read my mind. Okay, so we built a system that can detect Arabizi that is nestled in with English with about 98.5% accuracy. We trained a transliterator that converts Arabizi to Arabic in context, and this gets about 88.7% accuracy. The training set for the Arabizi to Arabic is publicly available. So if you want it by any means, feel free to ask for it. And I would like to thank Boeing for funding some of this work. Thank you. Questions? Go ahead.
Actually, one thing Kareem did not mention is this work is so fantastic. It's already been cited several times before it was even published. Because in fact, he did the work 2 years ago, right? And we have used his data and used it to publish versions of systems also that extended it. And also there was a poster today of work at the LDC that in the initial annotation used some of the data with our system. So I definitely think, when you look at all of this work, there's a lot of work going on in Arabizi. I give Kareem the credit for the first effort to do this, but there's also now like 4 different publications that should be looked at.
Thank you.
So it's fine. Just,
Thank you.
yeah.
Thank you.
Yeah. So for the detection, you're using kind of the context of the source, let's say English and Arabic. But when you detect that, when you do the conversion, you are kind of regarding the context of the source.
Yes. So basically, this when the work was done, we made a binary decision where basically we said this is Arabizi, and if it's Arabizi and we detect it as Arabizi, we're just going to convert it. Okay? And if it's English, we're not going to touch it. This may be a bit suboptimal in the sense that it might actually make sense to try to convert to Arabic, and then use the conversion, use the probability, like the language model probability after conversion as an extra feature. So, but no, we haven't tried that, but it actually makes perfect sense. Dr. Sameh?
Yeah. You said that you remove repeated characters.
Yes.
I think this may cause some ambiguity.
Sure.
Because if you say, for example, kitir, and then with E,
Mm-hmm.
and then you remove these E's to only one E,
Sure.
this could be kitr, which is ambiguous. You are moving from an adjective to a verb.
Sure. So if you want to know exactly what we did, we had work that we published earlier about a couple of years ago that explains in more detail. I mean, it's not just a matter of removing repeated letters. It's basically removing repeated letters to a point where the language model says this looks like the most probable thing to do. Okay, because you have words that have repeated characters, and that's fine.
So just right for this, Allah will never be that.
It will stay Allah. Yes.
Is it fair to say that you are doing some sort of character level machine translation, but without a language model, and you just output a 10 test list, which you restore afterwards with a language model?
Yes, sort of, yes. So you are doing character-based, yeah. You could have potentially, now that you mention it, is that you can run a full-blown, machine translation, and then, the system is going to learn the the character level language model in the process also. You can probably do that.
It doesn't make a lot of sense in the setup because the scraping data is just words. It's just that there's just one single word transliterated. Using a machine translation model to get the full power of the phrasal modeling would make sense if you use the Arabizi data, which had a poster there. I know, but you're still working within a word. It's actually quite true. It makes it end up being the same as what you did.
But it is similar to have just a monotonic kind of system, but with the power of combining both the mapping model and the language model at the same time. Not in two different stages.
So,
You have the current data Arabizi view, the correct one. You think in a different way? You have current data.
no, I will not think in a different way. The same way, because the data will be very, very sparse.
I'm not sure if like your tweets are mostly Egyptian tweets or just for all Arabic people.
We really didn't care. So actually, the tweets that basically we put lang : AR, and we didn't do any kind of dialect detection of any kind. So you're getting lots of tweets from all over. MSA, Egyptian, Levantine, whatever you see is whatever you get. And it's the same case with the Arabizi also. We didn't filter on any dialect.
So you think like your results would be the same for Tunisian, for example, tweets as compared to Egyptian ones?
I would hope so. I mean, given how valuable Tunisia is, I would definitely hope so.
It's different from the Egyptian
Yeah.
one. So it's different from the Egyptian one.
So that's
Yeah.
actually my question, which is, assuming that you find, you know that you have variety in how people spell.
Sure.
That's a given, but suppose there is some systematicity in that variety. For example, French-speaking regions will use sh as ch.
Sure.
English-speaking regions.
We use the SH.
Is that going to make your task easier or harder, or?
So I think there was an inherent bias. I mean, to answer your question and Wajdi's question, in the sense that, when I thought of stop words, I thought of Egyptian ones because these are the ones that I'm used to. So I got ihna and, awaz and so forth. So there was some sort of an initial bias to two things. So your comment is correct in the sense that, we're probably getting more Egyptian and probably more Levantine as opposed to more Maghribi or North African, Northwestern African, dialects there. Perhaps if we can enrich, the data set that the keywords that we were collecting with, we may be able to get broader coverage. But given that you get broader coverage, I think even, the system would work even with, basically it would just learn more mappings, and the language model is going to constrain at the end what you can get. So it can work actually with multiple dialects simultaneously without probably much loss in accuracy.
Just I have a small comment on the issue of, as you said, Tunisian. I think the Twitter API, so most of the time doesn't plug them as Arabic, so it's not something as French or Spanish. I think that's
Even if they're written in Arabic characters?
probably the one that are written in Arabic are very minimal. I mean, I did the experiment where I was collecting by geographic tag and see how much of them are Arabic. Very minimal. Some of them they find like Spanish, English, but not Arabic.
Can I have your comment on this?
So,
Very quick comment.
because Hazim Al-Hajj had the question also in the front.
Just
Okay.
a comment on
Go
this,
ahead.
because I have this concentrated stock words. So we had in previous work, we had this dialect stock words, which is statistically generated. We just found most of the frequent words and we tagged it as a stock word or whatever people call it. Stock words or not. So what we did, we transliterated them, and whatever transliteration we run a query on Twitter and we check if this is out of it is mostly dialect, we use it.
If it's not, we did like lab. It's not always. It's like can be in different languages. But إحنا, because of the 7, it's purely Arabic. So it's not biased to any dialect. It's just whatever the statistics of we get.
Okay.
So that's